Okay, Hannah, so this is geometry, lesson 6, 7, and 8. We're going to work with the Pythagorean theorem. I'm going to break these up into 3 different videos. The first video is going to be on Pythagorean theorem, just how it works. Distance will be the next one. And this is using like graphs and understanding the distance between 2 points on a coordinate plane and coming up with some calculations for that. And then we're going to work with applying the Pythagorean theorem using word problems. So before we do that, something that's really important to know is square roots. So I think we've talked a little bit about this, and even in MTSS we did this. So when we have a number squared, like 1 squared, so 1 squared equals 1 times 1. So the square root of 1 equals 1. And then when we have 2 squared, we get 2 times 2, which equals 4. So the square root of 4 equals 2. Then if we have 3 squared, we have 3 times 3, which equals 9. So the square root of 9 equals 3. And then 4 squared equals 4 times 4. Square root of 16 is 4. And then we have 5 squared, which equals 5 times 5. The square root of 25 is 5. And then 6, the square root of 36 equals 6. 7 squared is 49, so the square root of 49 is 7. 8 squared is 64, so the square root of 64 is 8. 9 squared is 81, so the square root of 81 is 9. 10 squared equals 100, so the square root of 100 is 10. All right, so these are all called perfect squares because the square root of these numbers is a whole number. So then you might get like the square root of 3. Now the square root of 3 falls in between the square root of 1 and 4. So the square root of 3 is going to be in between 1 and 2. So it's going to be 1 point something. So in order to figure that out, you kind of have to estimate. Now I can use my calculator. There is a square root button, so I can say the square root of 3 is 1.7, and so on. But to find the estimation of that, which usually is all you have to do in math, is come up with like the nearest tenth or the nearest hundredth of a non-perfect square. So for this one, for the square root of 3, I know it's going to be between 1 and 2, and I know 3 is closer to 4, so I know whatever my estimation is, it's going to be closer to 2 than 1. So obviously we just looked at it and it's 1.7. So to figure that out, I would try 1.7 times 1.7 or 1.7 squared. 1.7 times 1.7 equals, and our key number here is 3. And that's pretty close to 3. Now if I wanted to try 1.8 squared, I could. And that is, so we had, sorry, I didn't write that down, equals 2.89, and the square root, or the 1.8 squared, 1.8 times 1.8 equals 3.24. So because 2.89 is only 11 tenths away from 3, and 3.24 is 24 tenths away from 3, this one is obviously closer to 3. So we're going to estimate the square root of 3 as 1.7. So that's how you estimate the square roots of non-perfect squares. So that's really important to know because the Pythagorean theorem uses square roots and it's not always perfect squares. So let's go ahead and jump into this and see what we're going to need to do. Though in a right triangle, this only works for right triangles, the side opposite to the right triangle is called the hypotenuse. The hypotenuse is always the longest side, and the other 2 shorter sides are called legs. Leg A, leg B. Now these can be interchanged, it doesn't matter. You can call this A or that B. The lengths of the legs and the hypotenuse are related by the Pythagorean theorem. For a right triangle with the legs of length A and B and the hypotenuse of C. So we call this A, we call this B, we call this C. So the Pythagorean theorem says that if you square one leg and add it to the square of another leg, it should equal what the hypotenuse is squared. So for example, what's my favorite one? 416 plus 9. So I think my favorite one is 4, 3, and 5. So if leg A is 4 and leg B is 3 and the hypotenuse is 5, let's say like centimeters. If I didn't know one of these, I could figure it out by using the Pythagorean theorem. So let's pretend like I don't know that this is 5 centimeters. So I could do 4 squared plus 3 squared equals C squared. So 4 squared equals 16, 3 squared equals 9, C squared. So what's 16 plus 9, 25. And so then to find out what C is, you got to think what times what equals 25, or what squared equals 25. Or another way of saying that is the square root of 25 equals C. What's the square root of 25? 5 equals C. So then I just proved that. And then there's other ways that, like, if you don't know one of the legs, you can figure it out too using algebra. So let's practice using this one. So let's see. In this triangle, we need to find x. There's x. So I know the hypotenuse is 8 because it's directly across from the right angle. I know one of the legs is 5, and I know one of the legs is what represents as x. So I'm going to plug those numbers into my Pythagorean theorem. So we've got 5, or substitute the values with the equation. 5 squared plus x squared equals 8 squared. Simplify to solve. 25, 5 squared equals 25, plus x squared equals 8 squared, which is 64. So in order to get rid of this 25 and to solve for this x, I'm going to subtract 25 from each side. And so now I have x squared equals 39, and I need to find what the square root of 39 is. Now I could simply just say 39 square root, and I've got this big long number. And I would round this to the nearest 10th, or I guess in this case, we're gonna round to the nearest 100th. And so it would be rounded to 6.24. Now to actually do that without using that square root button, which you're gonna be asked to do at some point in your mathematical career, you would look at your chart and say, well, I'm trying to find the square root of 39. It falls between these two, doesn't it? 39. So it falls between the two whole numbers of 6 and 7. So you know you're gonna have 6 point something. Now 39 is closer to 36 than it is to 49. So you know your number is gonna be closer to 6 than 7. It's actually probably even gonna be less than 6.5. So I would try 6.4 squared. Now we already know it's 6.2 according to our calculator, but I just want to show you like how you would guess and check this. So 6.4 squared, and you can use a calculator for this work, it equals 40.96. Now our target number is 39, so I think we can get a little bit closer. So now I'm going to do 6.3 squared, 6.3 times 6.3 equals 39.69. Now that is getting a little bit closer, but in this lesson, they want you to go to the nearest 100th. So I need to add another number here. Now I know it's gonna be less than 6.3 because the answer here is over 39. So I'm gonna try 6.25 squared. 6.25 times 6.25 equals 39.06, getting pretty close. And so obviously we already know it's 6.24, so we're gonna try that. 6.24 times 6.24 equals 38.9. So it's 1/10 away. And I would actually even say this was, it's like so this is 700ths away, and this is 600ths away. So I'd even say this one's probably closer, even though they have 6.4 here. I would even say this is more of an exact estimate of this. But if you got, as close as you can get it to get to your target number, which is the square root of 39, would be great. So find 3 whole numbers that satisfy the Pythagorean theorem. So we did this one already. There's a ton, they're called Pythagorean triples, and there's a ton out there. I have not had them memorized. I think in MTSS, you may have been in that class that we did this and practiced our Pythagorean triples. But just to test them out, you just plug them in to see if they work for whole numbers. We know that 3, 4, and 5 work. Off the top of my head, I can't think of like another one that works. This is the one that we use for the Montessori materials, so that's why I remember it. But let me look up another one and we'll try it. Pythagorean theorem. Triples. All right, 5, 12, and 13. 5, 12, and 13. So to test that theorem out, if these are perfect, if this is a perfect triple, meaning they're all whole numbers and they will equal each other, the 2 smaller numbers would be the legs, and this is going to be the hypotenuse, or the C. So we would do 5 squared plus 12 squared equals 13 squared. And we're trying to see if this equals each other. So we know that this is 25. We know this is 144. And this is 169. So 25 plus 144 is 169, which equals 169, so that works. Now you could try any 3 numbers, like we could try 6, 9, 15, and you could try to see if that works using the Pythagorean theorem. So like 6 squared plus 9 squared equals 15 squared, and see if that works. This is 36 plus 81. 225. Obviously, 36 plus 81 does not equal 225, so this would not work as a triple. That does not, you can't have a right triangle that has these lengths. All right, so let's keep going. See what else we need to do with this. The 2 legs of a right triangle measures 4 and 6. Find the length of the hypotenuse. Substitute the values into the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So let a be 4, let b be 6. Substitute the values into the theorem. So 4 squared plus 6 squared equals c squared. So we've got 16 plus 36. So c squared is going to equal, so I don't like the way they flip these around. I would say, 16 plus 36 equals, so 52 equals c squared. That's how I would write it. And then you need to think, what times what equals 52? 52 is not a perfect square. So the c squared equals the square root of 52. And then in order to find the square root of 52, so c, we need to figure out, now you can just say, okay, square root of 52, there it is, 7.21, 7.21, 1, I mean, there's that big long number, and they want you to round it. So 7.21111025 is rounded to 7.21. But in order to kind of figure that out using estimation, you would say, well, the square root of 52 falls between the square root of 49 and 64. So you know it's going to be 7 something. And then it's pretty close to the square root of 49, right? So it's going to be closer to 7 than 8. So we already know that 7.2 works. So we would find 7.2 squared. 7.2 times 7.2 is 51.8. That's only, and this is only 1600ths away from 52. So I would say that's pretty close. So the hypotenuse is the square root of 52, which is estimated to be 7.2. Is the triangle a right triangle? Now, it looks like a right triangle, right? But you have to prove it using the theorem. Now, only right triangles can only be formed by if you square this number, add them together, and then the square root of whatever this would, or then square this, and they'd have to equal each other. No, you can't form a right triangle with any other types of lengths. They've got to be equal. So I think we already did this one on the previous page, so we know it is true. So the theorem is a squared plus b squared equals c squared. Let a equal 5, b equal 12, and c equal 13, because we're trying to figure out if this is the right triangle, so that would be the hypotenuse. So 5 squared plus 12 squared, question mark, equals 13 squared. I like that because we don't know if it equals. So 5 squared is 25, 144, 169. So this added together is 169. So the equation is 2. It is a right triangle. It does work. All right, explain how the Pythagorean theorem relates to the three sides of a right triangle. So A and B equal the legs, and C equals the hypotenuse. I don't know how to spell hypotenuse. There it is. Hypotenuse. Explain how to use the converse of the Pythagorean theorem. So the converse, is that what they use this? The converse right here. So that's when you use algebra to figure out what one of the legs are. So the converse of the Pythagorean theorem states that if the lengths of three sides of a triangle satisfy the equation, then the triangle is a right triangle. This can be used to determine whether or not a triangle is a right triangle when all the side lengths are known. So it's just proving the triangle is a right triangle. All right, so we're going to use the Pythagorean theorem to find the missing lengths. So we already know that this is a part of a triple, so we know x is 5, but to prove that, 4 squared plus 3 squared equals c squared, 16 plus 9 equals c squared, 25 equals c squared, the square root of 25 equals c, and then what is the square root of 25? 5 equals c. So x equals c. All right, this one, we're gonna need to find the leg. So we're gonna say this is A, this is C, and this is B. So 9 squared plus x squared equals 15 squared. So we've got 36 plus x squared equals, isn't 15 squared 225 times 15 equals 225. Get rid of this 36, get rid of this. So now we have x squared equals 189. 189 is not a perfect square. It is, now you would have to make your list a little bit longer because obviously it goes, our perfect square on this one only goes up to 100. But you could also just, and if it's not a perfect square, you can say, you can leave the square root on there. So it'd be the square root of 189, which is close to, well, 13 squared is 169, and 14 squared is 196. So it falls between the square root of 169 and 196. So you know it's going to be 13 something. So if you wanted to, you could say 13, let's say 0.2 times 13.2, 174, we're trying to get to 189, so 13.4 times 13.4, 179, that's getting a little closer, 13.5 times 13.5, 182, a little bit closer, 13.6 times 13.6, 184, 13.65 times 13.65 equals a little bit closer. So I would round it to 13.7 even, because that's about as close as you're gonna get. And what really is it? 189 square root 13.74. So we're pretty stinking close there. All right, so this one we can say this is A, this is B, and this is C. So x squared plus 6 squared equals 8 squared. So x squared plus 36 equals 64. Get rid of the 36. So now we have x squared equals 28. So x equals the square root of 28. Now, square root of 28 is not a perfect square, so you can leave it like that. Or you know that the square root of 28 falls between the square root of 25 and 36, so you know your number is going to be between 5 and 6, so 5 point something. Now, 28 is closer to 25, so it's probably going to be maybe around 5.4. That's 29. That's pretty close. 5.3. 28. That's really close. So you know it's going to be around 5.3. All right, this one, we don't know what the hypotenuse is. So you've got A, B, and C. So 5 squared plus 5 squared equals C squared. So 25 plus 25 equals C squared. 50 equals C squared. The square root of 50 equals C. Now, 50 is not a perfect square, so you can leave it like that. Or know that the square root of 50 falls between the square root of 49 and 64. Now, 50 is pretty close to 49, and the square root of 49 is 7, so you can try it out. 7.1 times 7.1 equals, that's pretty close. So you can say square root of 50 is about 7.1. All right, so what you're gonna do is determine whether or not the triangle is a right triangle using the Pythagorean theorem. So these are, I don't think any of these are Pythagorean triples, which means they're not whole numbers, but you're gonna use the Pythagorean theorem to try them out and see if they are equivalent. Now, you can use your calculator for the square roots. It's totally fine, just as long as you understand how to find them mathematically. Here, find the missing length. So you're going to find out what the hypotenuse is using your theorem. This can be A, this can be B, and this is C. And use your calculator to figure that one out because there's a decimal there. Which means this is not a perfect triple, or it's not a Pythagorean triple because those aren't going to be whole numbers. And so you can leave your x in the square root, or you can estimate to see what it is as a decimal. And then one leg of a right triangle has a length of 4.2. The hypotenuse is 10.1. Find the length of the second leg. So you can say this is A and this is C. So you're trying to find out what B is by using x. And then determine whether or not the triangle is a right triangle using these. Now remember, so you're going to have to estimate these, right? So the square root of 24 falls between the square root of 16 and 25. So you know it's going to be 4 something. It's pretty close to 25. So you know it's going to be like closer to 5 than 4. So like 4.9 maybe. 4.9 times 4.9 equals, that's pretty darn close. So I would say this is 4.9. And then 57 falls between 49 and 64. It's pretty much smack dab in the middle. So I would say it's like 7.5. times 7.5 equals, that's pretty close to 57. Maybe even try one more. 11.6, 57, that's pretty close too. So I would say that's, what did we say that was? 7 point, even like say 7.55 maybe. And then 9 would be your hypotenuse. The biggest one's always the hypotenuse. So to do that, now you can say the square root of 24. So what you could do on your calculator is go 24 square root plus 57 square root equals, so that's what the square root of 24 plus the square root of 57 equals. And then, so that would be like 12, 8, 8. So this would be these two added together. A squared plus B squared equals 9 squared. Does it? No, it does not work. This is the square root. So, and or the square root of 9 equals 3. So those do not equal each other. That is not a right triangle. So then this one, I would find the decimal forms for these first. So, or I guess you don't have to. You can say 3 over 7 squared plus 4 over 7 squared equals 5 over 7 squared. So this is like 3/7 times 3/7, which equals 9 over 49. And this is 16 over 49 equals 25 over 49. And then what are these put together? 25 over 49 equals 25 over 49. So yes, this one is. This one is not. Okay, and then go ahead and do these on your own. And let me know if you've got any questions over Google Chat or email.